Good day. I am Heartful Amgimari together with my group mates.
So we are now going to talk about general relativity. The theory of general relativity attempts to explain within a single framework almost all the laws of physical universe. It was formulated by Albert Einstein to account for gravity. He thought of homogeneous gravitational field as completely equivalent to a uniformly accelerated reference frame. This refers to the principle of equivalence, which Einstein considered as his happiest idea and is the backbone of the general relativity. It is said by Santiago and Silverio in the year of 2016.
The principle of equivalence. According to Padua and Crisostomo of the year 2007, the principle of equivalence states that an inertial reference frame in a uniform gravitational field is equivalent to a reference frame in the absence of gravitational field that has a constant acceleration with respect to the inertial frame.
Consequences of general relativity. One of the key ideas in the theory is that gravitation is a warping of space and time around a body of matter. An object moving through such region of space in general follows a curved path rather than a straight one and may even be trapped there. Padua and Crisostomo, 2007.
Massive entities like stars and galaxies are able to warp space and time considerably that even the behavior of light is affected. In the absence of gravitational field, light would follow a straight path. The presence of massive objects would bend the light path around the gravitational field of the said objects. The implications of the general theory of the relativity is not always straight and rectilinear as once envisioned, but in certain places curved.
Another consequence that arises from the principle of equivalence is that light is bent in the gravitational field. This ability of gravity to bend light just like a lens is called the gravitational lensing. Light can be bent when it travels along a warped space near a massive object. This was confirmed in 1919 by measuring position of stars during a solar eclipse. Today, gravitational lensing is measured by the deflection of radio emitted by distant galaxies called quasars.
The idea that gravity affects light is seen in the concept of black hole. A black hole is generally considered to form from the gravitationally collapsed remnant of a star. Such an object has a great density and a very intense gravitational field that nothing can escape it. A black hole can also be a bottomless pit in the fabric of a space-time. Even light cannot escape the intense gravitational field of a black hole.
Gravitational result is another result of the general theory of relativity. Gravity affects time by causing it to slow down greater the gravitational field, the greater the shortness of time. Another success of the general theory of relativity is about the explanation of the advanced perihelion of planet Mercury.
The perihelion point. The point closest to the Sun of Mercury moves forward in the planet orbital motion. Previous prediction of actual rate of advance falls short from actual observation. Yet when calculation using the general theory of relativity were used, the advance was predicted perfectly. Mercury is a planet as an obviously elliptical orbit and is also closest of all planets to the Sun.
Mercury is one of the most affected by the gravitational relativistic time effects. Relativistic effects apply to all systems. It may be that these effects are very obvious for atomic particles and light. They also apply to real clocks and to us, Padua and Crisostomo 2007.
Global Positioning System or GPS. The general theory of relativity may seem to be an exotic bit of knowledge with little practical application. In fact, this theory plays an essential role in the Global Positioning System or GPS, which makes it possible to determine your position on the Earth's surface to within a few meters using a handheld receiver.
The heart of the GPS system is a collection of more than 2 dozen satellites in very precise orbits. Each satellite emits carefully timed radio signals, and the GPS receiver simultaneously detects the signal from several satellites.
According to Young and Freedom University Physics 2012, the receiver then calculates the time delay between when each signal was emitted and when it was received, and uses this information to calculate the receiver's position. To ensure the proper timing of the signals, it is necessary to include corrections due to the special theory of relativity, because the satellites are moving relative to the receiver on Earth, as well as the general theory because the satellites are higher in the Earth's gravitational field than the receiver. The corrections due to relativity are small less than 1 part in, but are crucial to the superb precision of the GPS system.
So what is the point of general relativity? It explains gravity based on the way space can curve, or to put it more accurately, it associates the force of gravity with the changing geometry of space and time.
What's the effect of general theory of relativity? General relativity predicts that the path of light will follow the curvature of space-time as it passes near a star. What is the importance of relativity? The importance of the special theory of relativity is that it helps us understand time and space more.
What does relativity tell us about the universe? General relativity lets us calculate and predict exactly how anything with mass will warp space-time, and how the gravity caused by the warped space-time will not affect just the matter but the space, time, and light around it.
What is the importance of relativity in our daily life? A world without relativity would be a world without fast food, radio televisions, radar guns, the global positioning system, and more.
What are the two main points of Einstein's theory of relativity? The theory of relativity was based on the two main postulates. First, that the speed of light is constant for all observers. And second, that observers moving at constant speeds should be subject to the same physical laws.
What are the outcomes of theory of relativity? Some of the consequences: additional time dilation, clocks run slower, and differ gravitational waves.
How did the theory of relativity impact society and change the world?
They redefine human understanding of space, time, and gravity and change our daily lives, including modern electronics, nuclear power, and your GPS navigation.
What is his special theory of relativity history? In his 1905 theory of relativity, later named the special theory, Einstein's insistence that the laws of physics must appear identical to observers in uniform relative motion lead to the prediction that space and time are neither independent nor absolute.
Is the theory of relativity proven? Scientists have demonstrated that Einstein's theory of general relativity is correct to a remarkable degree of accuracy.